going to call it slope of the tangent line. So we had this. This is the slope of the tangent line, and somebody said secant, and the secant line is the average rate of change. Slope of the tangent line is the derivative. And we know, and I want to be quick about this, so we can get through the stuff that is new. The derivative is the limit, and you have to recognize that, as h goes to 0 of f of c plus h minus f of c all over h. Remember that? How long have we been doing it? A long time. I don't know about you, but I'm tired of it. Okay? And it's hard. If you have something like x plus 3 to the 9th power, doing this expansion is not easy. So we have to find other ways to do it. There are rules and shortcuts. But this is what I want you to do, that right there on this particular quiz. Any problems with that? No, that should be okay. Okay, so what we're going to do today is we're going to do velocity, average velocity, instantaneous velocity, and speed. Velocity is the change in distance divided by the change in time. That's the average. If you remember, distance equals rate times time. Remember that from 9th grade physical science? Should have had it. And so the rate, or the velocity, is equal to your distance divided by time. Remember that? Your instantaneous velocity is the derivative. So I don't really have any room here. We're going to skip this. It's not that hard. V instantaneous is equal to the derivative. Now the derivative operator is a d, and it's the change in the distance, and I want it as time changes, not x, so it's dt. That's a derivative of the position with respect to time. I know in your science class they use d. Unless you're in physics, calculus-based physics, they'll use s. We don't want to use d. S is position. Thank you for reminding me. S equals position. I'm so used to it. That's what they use in physics. Because they don't want to do dd, dt. And you can hardly say it. Okay? So let's write this out. S equals the position. The velocity is equal to the change in the position as time changes. See, it doesn't make sense to talk about your change in position as x changes. Think about driving your car. You know, if I drive to Minneapolis, it's 30 miles. It takes me an hour. I'm traveling at 30 miles per hour. So you're talking velocity. You know those things. Don't separate yourself from the real world. And what's the next thing? Acceleration. Oh, I'll get the speed in a second. Acceleration is the change in your velocity. And if you don't know that, we're in trouble. Because we all accelerate. When you sit at a stoplight and you put your foot down on the accelerator, not only does your position change, but your velocity changes, doesn't it? When you're at the stoplight, you're going 0 miles per hour. And you have to get up to 30 miles per hour. So acceleration is the change in the velocity as time changes. But you know what? That's the derivative of this. Acceleration is the derivative of the velocity. Whoops. Don't want that. I may have to do a video. And you remember how we wrote that? How many d's do you see? Second derivative. D squared s. How many dt's do you see? dt squared. That's the second derivative. I did do that. So it's the second derivative of your position. And we can go one step further. We can talk about how the acceleration changes. Now you just have to think for a second. That's the third derivative of your position. So you are driving along and you are accelerating, and you drive into a brick wall. What happens to your acceleration? It changes, right? It changes. And that's the part that hurts you in a car accident, and it's called the jerk. So if you hit another car and you go forward, the jerk, that's what hurts you. It's the change in the, not so much the change in the velocity, the change in the acceleration. Your velocity is constant, that'll also hurt you. But if your acceleration is not, that's the problem. Most of the time you're accelerating, or somebody else is. Take your pick. Okay, what else do we have here? Setting up word problems, which we'll do. Instantaneous rate of change is a velocity. Oh, and speed. Speed is related to velocity. And your speed is your absolute value of your velocity. Yes, you have to know that on the exam. And so they will ask you for your speed. It's the absolute value of the velocity. So, you know, I'm going 30 miles per hour towards Minneapolis. That's no big deal. I don't care what direction I'm going. Velocity has direction. Speed does not. And so we'll do some problems. So we're going to start with a physics problem. Are we okay with what all the symbols mean now? The videos were there. I moved them over on purpose. Now, you don't have to memorize this, but this is just a free fall motion. Who's in physics? Who has had physics? Most of you have not had physics? I thought they moved it to juniors. Okay. Well, that explains why Mrs. Hersman's class, because she has more seniors than I do. That explains why her class knows more about the physics. Free fall. Well, you know some of this from math class, actually. Now, if you drop an object, or you throw an object up in the air, this is a constant acceleration. It only applies to a constant acceleration. And I know you've done problems like this in higher algebra, or you should have. We use G for the acceleration symbol, and it's negative because when I drop something, the acceleration due to gravity is going down. So when you talk about a force, it's going down. So this is a negative acceleration. If I were to accelerate it going up, that would be a positive acceleration. Same thing with left and right. This is a positive, where this is a negative. It should make sense. We do have signs. And these are the formulas. This is the feet formula. This is the meter. This is position. I already talked about that. I'll give all that to you. And it's the second derivative, speed right here. That's what you got to know. Generally speaking, when we get further on, we'll do more with speed, and we'll look at it as a different thing other than a derivative. And you are going to be using a calculator for this. Almost always will you be using a calculator to do the absolute value of a function. Because it's too hard. Because if a function does this, you have to absolute value it. So that means you have to find out where these zeros are. You have to flip that up and over. So on the exam, it will be in the calculator part. It'll be very rare, unless it's an easy function, which that's not. So let's do this problem. And it gets a little squishy. Sorry about that. Oh, wait, I'm going to skip that one. I'm going to come back and do this one, the clip. Let's do the physics problem. Then we're going to go on and do 19. Yeah. That's right. Second derivative is the derivative of the derivative. Okay. I know you don't have a lot of space, so if you need extra paper, I got some orange paper there. Come and grab some. You're standing on a cliff that's 100 feet above the ground. And actually now is when I'm kind of glad you don't have the physics. Because we're not going to change our coordinate system. We're going to keep the coordinate system on the ground. So here's my cliff. Here's the ground. And we're going to put our coordinate system right in here. That's where we're going to put it. Now in physics, I guess they're putting it up at the top, which doesn't make sense to me. I never learned it that way. You can. When I'm doing the solar system, I do want to transfer my coordinate system over to wherever my problem is I'm working on. So if I'm working out on Pluto, I want my coordinate system out on Pluto. I don't want to be taking all those distances with me. So anyway, here's my cliff, and it's 100 feet above the ground. The secret to doing these problems is to draw a picture and label what you know. And I think I'm going to do a little bit different tack than I did before. We're going to write down what we know. So that in the beginning, we're going to throw a rock up in the air, right? And we're going to give it a velocity, because if I don't give it a velocity, is this going to go up? No. So I've got to give it a speed. It's going to go up in the air, it's going to do this, right? You know what? That's a parabola. There's the other half. The other half's behind the cliff, but it's not really there. So in the beginning, when t is equal to 0, what's our position? How far above the ground are we? 100. What's our velocity? We have to give it a velocity, remember? 2. Okay. Then the object goes up in the air, and then what happens here at the top? What's 0? No, we can't use the word it. Velocity is 0. So t equals, well, I don't know what t is. Put a question mark. These are things we have to find. Velocity is 0. What's the position? I don't know. Okay? These are things that are implied in the problem. You are not, it's not explicitly stated, but you know it because you know what happens in the real world. How about at the bottom? I don't know what the time is. I don't know that either. What's our position? 0, and our velocity is, I don't know. Okay? If I were to drop the rock, then the velocity would be the same in the beginning and end, but it's not. It's right up in the air. Yes, it has stopped after it stops, but when it hits the ground, think about it. When it hits the ground, is it hitting with a 0 velocity? What's the velocity right before it hits the ground? It's not 0, right? That's why physics is hard. It seems so simple, but it's hard. Okay. Now, I have to come up with a position equation, which will give you. Does this look familiar from math class? Whoops. That would not look familiar because it's wrong. AT squared plus the initial velocity times the time plus the initial height. You should have seen this in math class. Yeah, for physics class you would see it, but you should have done it in math class. I used to teach it in pre-calc because I know I've taught it. So the acceleration, now on the exam, if they don't ask for, here's the deal. If they don't ask for units, I'm going to say always put units in. If you have the units, put them in. If you don't have the units, then just ignore it. But always put them in, because if they ask for the units and you don't put them in, you're going to lose points. If they don't ask for the units, but they have them in, that's okay, unless you do it wrong on the units. It's still okay. They won't mark it off. Okay, so I'm in feet, so guess what I have to have for A? Negative 32 feet per second squared. That's why you need that little chart. So the formula is going to be equal to 1/2. Why is it negative? Because it's going down. What's the initial velocity, which is going up? Plus 2, right? If it had been dropped at negative, if you were throwing it down at negative 2, you'd be negative then. And the initial height is 100. So there's your position equation. Let's clean that up. I don't want that to happen. So S equals negative 16t squared plus 2t plus 100. Probably should have asked that question first. What's the position? But it didn't. So what's question A? Find the velocity. How do you find the velocity? How does the velocity relate to the position? I'll find it. Where's the velocity? It's the change in the position as time changes. It's the derivative. Now here's the next thing that's kind of hard. When I take a derivative, it's an operator. When I add 2 and 3, the operator is the plus. It's an operation. When I square root something, it's an operation. It's telling me to find the number I multiplied by itself. So when I take a derivative, it's an operation. And the symbol for the operator is d, dt or dx, whatever the variables we're working with. It's dt in this case. So that's the operator. So I'm going to operate on this. So I'm going to take the derivative of both sides. And so now I'm going to take the derivative of this one. Let's put it on the side, I think. I don't have to. And I'm going to do the derivative of that one. And then I'm going to do the derivative of this one. What's the other word for derivative? Slope. Okay. So I don't know what the derivative of s is with respect to time. It's called the velocity. So v equals ds dt equals. What's the derivative of this thing? It's a negative 16t squared. There. So what do you do with these two numbers? Just do the homework on 3-3? You multiply. I don't want to do the definition. You can if you want, but I don't want to. It will take you forever. Negative 32 what? T. What's the slope of 2t? 2. What's the slope of a horizontal line? 100. So velocity equals negative 32t plus 2. Question arose in the last class. May I use my physics formulas? No, you have to use the calculus. The physics formula for this one in particular is the velocity equals the acceleration times the time plus the initial velocity. Because you didn't understand where those formulas come from. There it is. There's acceleration, there's initial velocity. That's all it's asking for on A. That wasn't hard, was it? Just follow the directions. What's B? Now it gets hard. What's the maximum height? Okay, to find the maximum height, you need the position, right? I'm thinking out loud. My position is S equals negative 16t squared plus 2t plus 100. So if I want the position, what do I have to know? No, simpler than that. What do I need to know? No, I don't know any physics. What do I have to know to find the position? I have to find the what? The time for the what? What am I looking for? Maximum height? Maximum height. And when is the maximum height? When what? V is equal to 0. See how I'm thinking? Not skipping those thinking steps. You need to think it through. So 0 equals, sorry about that, negative 32t plus 2. You know how to solve for t, right? 32t equals 2. T equals 2 over 32, or 1/16. For some reason, I don't use 16ths that often. I don't remember it as a decimal. Because V equals negative 32t plus 2. Because we found the velocity in part A, right? Right there. Is that okay? So I plug in 0 right here. What you got to ask? If you're all asking the question, somebody else has got it. Same question. Okay. That's the time to get to the maximum height. It's a multi-step problem. You don't want to do this. So what do you have to do? You have to find the position when t equals 1/16. So you're going to put in, where's my position equation? Negative 16t squared. I am not going to take the time to do this, because this is just a matter of putting in your calculator and do it. And you're going to substitute in 1/16. And you know what? If this is a free response question, you can leave it. Don't do it, because if you do it wrong, you're going to lose the points. I don't want to see you lose points. That's silly. Okay. So we're just going to leave it, because we're lazy. And we want it right. Is that okay? That makes sense? Maximum height. To find the height, you need to know the time it takes to get to the maximum height. And that's why I have to use this piece right here. It's implied. So I'm thinking out loud. How do I get maximum height? Look at my picture. Slope of the tangent line 0. The velocity is 0 there. Okay. I think that's the toughest part. Slide down. So I put my position down. I need to know the time. Time happens, maximum height. When the velocity is 0, I find the time. And then, you know what they're all like. I don't want you to memorize it, but they're all like. What's the next question? What is the velocity of the rock when it hits the ground? Oops. Again, I'm going to look at the problem. I want to find when it hits the ground. Is this C? Yeah. So I want the velocity when it hits the ground. And that's why I had the picture there. Remember the picture here? It's hitting the ground here. I know something. S equals 0. And I know that the velocity equation is right here. Negative 32t plus 2. So V equals negative 32t plus 2. If I'm in physics class, I'm going to write that down, because that's going to tell me maybe what to do. What is it I don't know? I don't know the time it takes to hit the ground. Well, S is equal to 0 equals negative 16t squared plus 2t plus 100. Right? You want my programs, because you can use quadratic formula. But I'm not going to do it. I'm going to do it by hand. And I'm going to divide through by 2 because I want the numbers to be easier. Is that a problem to do that? Any problem with that? Because I want numbers to be easier. Because remember, quadratic formula is opposite of b. You have to do b squared minus 4ac. Numbers are ugly. They're not ugly, but they're not nice either. Okay, so we're just going to use quadratic formula. So t equals the opposite of b plus or minus. Don't show the substitution, just do it. B squared, which is 1. Now, here's where I do show substitutions. 4ac all over 2a. I'll even do that. There. Make it happy. Okay, what's a? Negative 8. Be careful with your signs. And 50, because you're going to get a square root of a negative number, otherwise you're not careful. And then first and last class I said, oh, I did it wrong, but no, I didn't. T equals negative 1 plus or minus 1 plus. Now, how did I do this the easy way? I multiplied 8 times 50, which got me 400, plus because of those. 400 times 4 is 1,600, all over a negative 16. I have to finish this because how do you interpret it is the problem. So T is approximately, well, when you're up at $1,600, you take $1 away from me, it's not going to count for anything. We've already done that idea. So this is about 40, right? So it's negative 1 plus 40 over negative 16, or it's negative 1 minus 40 over negative 16. Well, this is going to give me a negative number. Well, you know what that is? That's the time over here. Remember when I said the parabola comes down like this? That would be the time before you actually threw the rock in the air. If you were to do the mathematics, it doesn't make sense physically. So we're going to throw that one out. It doesn't make sense. And so this is negative 41 over negative 16, or 41/16. Oh, one space. That's the time. I didn't answer the question, did I? That's the time it takes to hit the ground. And when you're doing this, hopefully it'll be faster than this. Okay, so what's the velocity? I'm going to take the 41/16 and substitute it into the velocity equation right here. So v is equal to negative 32 times 41 over 16 plus 2. And I can do that in my head. Because how many times does 16 go into 32? Twice. So that gives you negative 82, sorry, plus 2, or a negative 80. Why is it negative? Because it's going down. Negative means it's going down. Not a lot of physics on the test, so you don't have to worry too much about it. I'll have to look at it again. I'll prepare you for that. I'm not going to let you see. Okay, what is the speed of the rock? Okay, its velocity. We can get this all squished in here. So the velocity is negative 80 feet per second. What's the speed? What is speed? It's the absolute value of that. Yeah, so it's 80. Okay. The hard part to me is drawing the picture, writing this stuff down here about what the velocity is. You do know things. Velocity is 0 here, and position 0 there. And then using that to help you find the missing pieces. What I did was I wrote the equation down and I said, what do I need? I need to know the time. How am I going to find the time? Well, the velocity is 0 there. Give me the time. Okay? Kind of okay? Let's do another problem. So we're going to come in and we're going to do the other one. That one. We have to talk about distance versus displacement. These are really important. Now, Mrs. Hersman came into the grade 4 class, but not grade 5. Sorry. So distance. Now you got to watch me. I'm going to start here. Here, watch me. This is the next one. Beige. This color. Yeah, it's that one. Yeah, I'm trying to pick up the pieces here. Sorry. It's this color. And I probably have extras. It's messing this up. Well, I was putting my extras up here, but I don't see them. I got a little line. You ready? Use a piece of paper. Doesn't matter. What's distance and what's displacement? Distance. Okay, I'm going to walk across the room. I'm going to get over here, and then I'm going to come back. Okay, Ashley? Is my distance 0? No. My distance is the actual distance you travel. I hate to be circular on that, but I am. But what about my displacement? Yeah, what's my displacement if I walk over here and then I walk back again? It's how far you are from your starting point. What's the distance from the starting point? Okay. So if I were to walk, from my room down to the main office and back again, my distance is not 0. But what's my displacement? It's 0. Okay. So you have to be careful with displacement. So if a function drops below the x-axis, you're going to have to use absolute values, and it's tricky. So generally speaking, it'll also be with the calculator. And velocity is the derivative, right? ESDT. What's the speed? Absolute value of the velocity. Remember, this is day 2, so you've already done this. Acceleration, what's acceleration? The change in the velocity with respect to or the second derivative of the position. Yes, you need to know that's the second derivative, because I could ask you for one. Kevin. Displacement is how far you are from, yeah. I mean, if I do this, okay, that's my distance. The red is my displacement. Okay. Yeah, that's hard. I mean, I don't think it's easy. Now, I want you to think about how do you, and this is really important. So important, I'm going to put little stars by this. Okay? I guarantee this on the exam every year. Every single year. Sometimes it's hidden, but it's there. How do you know if an object is speeding up? Let's take my pen. I'm going to throw this up in the air. No, let's drop it first. We're going to drop it. If I drop it, is it going to speed up or slow down? It's going to speed up. What's true about the acceleration due to gravity? It's negative, right? And it's falling, so its velocity, which is also a vector, is also going down. So what's true about the acceleration velocity if it's speeding up? They're going in the same direction. So A and B have the same sign. They could both be negative, or they could both be positive. It doesn't matter. It's speeding up. Okay, how do you know if an object is slowing down? Let's take my same pen, and I'm going to throw it up in the air. Is it going to slow down or speed up? Because acceleration is negative, but what's true about the velocity? It's positive. So acceleration and velocity are opposite signs. Doesn't matter which one's positive, which one's negative. Slowing down. Okay? So we're going to do number 19, because it's a homework problem. Well, I don't know if the homework problem is it's like one. And actually, it's not as bad as what I was thinking it was. I should get a motion on there, but it's not. Now, what did I do here? Okay, that's weird. Okay, you ready? I should have given you enough space. There is my position equation. S is measured in meters and T is measured in seconds. Oh, I said in the last class I couldn't see units. But I don't care. We're going to ignore units from just now because we want to get through this. Find the displacement during the first 5 seconds. How do I find my displacement? Remember how we found it? It's where you ended up minus where you started. So it's S of what? Where are you going to end up? S of 5 minus where you started, which is S of what? 0. So you put it in, and don't show the substitution. Do it. It's t squared, which is 25, minus 3 times 5 is 15, plus 2. And then don't be silly like me and forget about S of 0. And then it's minus S of 0, which is 0 minus 0 plus 2. So what's that end up giving me? 10, right? And since we're doing this in class, it's not on the solutions. It says it's in the smartboard. But you have access to all of last year's smartboards as well. You just have to go into last year's file. Find the average velocity. How do you find average velocity? Do you remember? Think about it. Your average speed is how far you travel divided by how long it takes you. So what is that? It's S of 5 minus S of 0. And they do this just like this on the exam. They lead you through the question. Over 5 minus 0. So that's 10 over 5, which is 2. Now, how do you find your instantaneous velocity? Oh, that's tough to get back to. If S equals t squared minus 3t plus 2, what's your instantaneous velocity? You have to do what's that? Find the derivative. Do I have to write the derivative operator, or can we just do it? No, I don't want to do t plus h. That's too hard. What's the derivative of t squared? 2t. What's the derivative of negative 3t? Negative 3. And what's the slope of a horizontal line? 0. So there it is. And then you're going to find it when t is 4. So now we want to find v of 4, which is equal to 4 times 2. Sorry, my board is just acting up. 2 times 4 minus 3. So that gives you what? 5. Okay. Which means it's moving to the what? It's positive, so it means it's moving to the right. And then it says find the acceleration of the particle when t is, or it's moving up, whichever. How do you find the acceleration? Acceleration is the derivative of the velocity with respect to time. It's acceleration. I want the derivative with respect to t of this thing. In other words, I want the slope there. What's the slope of that line? 2. So no matter where I am, the acceleration is always 2. So then at 4 seconds, is it speeding up or slowing down? I'm sorry, what? Yeah, there. Okay, is it speeding up or slowing down? That's a 3. I know, my board just is acting weird. It's the derivative of that. What's the derivative of 3? 0. Yeah. So the slope's 2. Keep thinking it's just slope. You know it's a line. What's the slope of the line? It's 2. Don't say, oh, this is calculus class. It's nothing special. Now, how do you know when the particle changes direction? What's going to happen? The particle goes to the right, and then before it can change direction, it has to what? It has to what here? It has to stop. So v equals 0. Again, you're going to have to be able to do this. So there's your velocity. Set it equal to 0 and find the time. We'll do much more with this later on. So if we solve that, I get 2t equals 3. So t equals 3/2 or 1.5. I know you guys do it differently than I do. So actually, when t equals 0, which direction is it going? No. When t equals 0, what's your velocity at 0? It's 2 times 0 minus 3. It's negative, so it's going left, and then it's going to stop and turn around and go right. what it's going to do. And we'll deal more with that later. We don't have time today. When is it at the minimum? When is it furthest to the left? And they're going to ask you this question on the exam. Wait till I start pulling them for you, because they're going to ask you that. Well, when is it further to the left? That's a minimum. Do you guys, you know what parabolas? You should have done this, but I don't know if you did. Do you remember how to find where the vertex was? It was x equals the opposite of b over 2a. Sorry, just acting weird today. b over 2a. Remember that? Some of you saw it. You should have seen it. If not, I need to make sure that my pre-calculus teachers see it, talk about it. But, you know, it's a vertex like that. What's true about the slope at the bottom of that parabola? It's 0. We know how to do this now. We're smart when we calculus. So what's y prime equal to? This is cool. What's the derivative of that? 2ax. What's the derivative of bx? What's the slope of this? Plus b. What's the slope of a constant horizontal? 0. And so the derivative is 0 there. If you solve for x, 2ax equals minus b. This is very helpful for you on the SATs and ACTs, if you didn't know this. There it is. That's the x-coordinate for the vertex. It comes from the calculus. So I could remember that because this is just a nice little parabola, right? I'm just going to rewrite this. S. So where does it reach its minimum? It's when the velocity is 0. So we already did the velocity. Well, let's do it again. It's 2t. Oh, no, it asks what is it? Where is the particle at minimum? Oh, it's a minimum when b is equal to 0. That was at t equals 3/2, right? From the preceding part of the problem. I'm just about out of voice here. Yes, because we just did that, right? And so all you have to do is evaluate this at 3/2. So s equals 3/2 squared minus 3 times 3/2. Let's see if I can do the arithmetic right today. So this is going to be 9/4 minus 9/2 plus 2. What's the common denominator? I know you go to decimals, but I don't want to do that. It's easier than that. What's the common denominator? 4. And this is going to be 4. Why do I have to have common denominators? What does a denominator represent? It represents if I took my pie, I'm dividing it into 2 equal pieces. That's what a half is. So I got to have the same number of equal pieces so I can add them up. I said that wrong. I have to have the same size. If I can't add them up, it doesn't make sense. If you think about it, then you'd be fine. That's 4ths, right? Plus 8/4. And then I add 9 and 8, which gives me 17. 17 minus 18 is negative 1/4. And that's your position. That's where you're going to be. So it's at, what was it? The 3/2. There's your time and your position. Okay. You can try the next problem if you want. It's problem number 20. Answers should be, well, they're on the smart board. They're not going to be, they're not going to be on the, they're not in the answers because I did them on the smart board last year. You'd have to go back and look at it. Oh, let me pause this. Stop it. Now I'm going to give you back all this stuff.